Mathematics was not invented, it was discovered. This is not a philosophical position. It is the conclusion of most mathematicians who have thought seriously about it. The rules of mathematics exist independently of humans. We didn't create them. We found them. 2 plus 2 equaled 4 before there were humans to notice. Prime numbers were prime before anyone counted them. The ratio of a circle's circumference to its diameter was pi before anyone drew a circle. Mathematics is the universe's operating system, and it has been running since before we arrived. Now, let's talk about something that should not exist. The number pi, 3.1415925, and then it continues, forever, without repeating, without pattern, without end. An infinite sequence of digits containing no structure, no repetition, no predictability. Pi appears everywhere, not just in circles, in the probability distributions of quantum mechanics, in the mathematics of waves, in the equations describing how heat spreads, in the statistics of random events, in the structure of DNA, in the spacing of prime numbers. Pi is in everything, nobody knows why. Now let's talk about prime numbers. A prime number is divisible only by itself, and 1, 2, 3, 5, 7, 11, 13, they continue forever, infinitely many of them. This was proved by Euclid 2,300 years ago and remains one of the most elegant proofs in mathematics. The primes appear random, their distribution looks like noise, and yet hidden within that apparent randomness is structure so deep and so strange that it connects to quantum physics, to the zeros of a function called the Riemann zeta function, to the energy levels of heavy atomic nuclei. The primes in the quantum world appear to be using the same mathematics. Nobody knows why. Now let's talk about Euler's identity. E to the power of I times pi plus 1 equals 0. 5 numbers. E, the base of natural logarithms fundamental to growth and decay. I, the square root of -1, an imaginary number that shouldn't exist but powers all of modern engineering. Pi, the ratio of circumference to diameter, the number that appears everywhere. 1, the multiplicative identity. 0, the additive identity. 5 of the most fundamental numbers in all of mathematics, in one equation, connected by addition, multiplication, and exponentiation, equaling 0. Mathematicians have called it the most beautiful equation ever written. It describes a relationship so perfect and so unexpected that its discovery felt like finding a secret the universe had been keeping. Nobody predicted it would be true. Nobody could have. It simply is. Now let's talk about unreasonable effectiveness. In 1960, the physicist Eugene Wigner wrote a famous paper titled The Unreasonable Effectiveness of Mathematics in the Natural Sciences. His observation, mathematics developed by pure mathematicians with no intention of describing the physical world, repeatedly turns out to describe the physical world with extraordinary precision. Non-Euclidean geometry was developed as pure abstract mathematics in the 1800s with no physical application imagined. Einstein used it 60 years later to describe the curvature of space-time. Complex numbers involving the square root of -1, a number that cannot exist, are the mathematical foundation of quantum mechanics. Without them, quantum mechanics cannot be written down. The mathematics came first. The physics followed. Every time. Why does the universe obey mathematics? Why does abstract human reasoning about numbers produce accurate descriptions of physical reality? This question has no agreed answer. It may be the deepest question there is. Now let's talk about infinity. Not infinity as a concept. Infinity as a mathematical object with internal structure. In the 1870s, Georg Cantor proved that some infinities are larger than others. The infinity of counting numbers, 1, 2, 3, forever, is smaller than the infinity of real numbers between 0 and 1. You can prove this. The proof is not complicated. The implication is staggering. There is a hierarchy of infinities, an infinite number of different sizes of infinity. Cantor's contemporaries called his work a disease, a corruption of mathematics. His ideas were attacked so ferociously that Cantor suffered a mental breakdown. He was correct. And now let's talk about the thing that broke mathematics itself. In 1931, Kurt Gödel proved something that should have been impossible. He proved that any mathematical system powerful enough to describe arithmetic contains true statements that cannot be proven within that system. Not statements we haven't proven yet, statements that are true, that we can never prove, No matter how long we try, no matter how clever we are, the proof that they're true exists outside the system. From inside, they are unprovable forever. Mathematics cannot prove all mathematical truths. The system is incomplete, necessarily, fundamentally, permanently. Gödel's incompleteness theorem is one of the most profound results in the history of human thought. It means that mathematics, the language the universe appears to run on, has holes in it, true things that can never be proven true. The universe's operating system contains statements it cannot verify, and it has been running anyway for 13.8 billion years, without error.